Totally different turn than sequences. Totally different turn. The unit 3 and unit 4 kind of go together. You guys remember in your geometry days talking about sine, cosine, tangent a little bit, SOHCAHTOA? We're going to get into that this unit. That's a big part of this unit. Here's what we're doing today. Taking an angle and graphing it on an XY axis. That's what we're going to do. Take an angle of 56 degrees. Show me what it looks like on the XY axis. So can we first talk about your knowledge of quadrants? There's 4 of them. That's a good start. Anybody know where the first one is? Roman numeral 1? You think you know?
Top right.
Top right, yeah. Top right is quad 1. And you know how they rotate? Where 2 would be? Counterclockwise. Yeah, so 1, 2, 3, and good old quad 4 right here. All right, good start. Good start. Next question. If I started here on the x-axis, and please don't do this, and I went all the way around, you know how many degrees I went? 360. And those 360 degrees are divided evenly into 4. So as I go from here, which is 0 degrees, now we can start copying this down. Go ahead, that's 0 degrees. To the top of the y-axis, how many degrees did I go?
90.
So at the top here is 90. So any angle between 0 and 90 will be graphed in the first quadrant. All right, keep going with me. What do you think's over here on this side of the x-axis? Buck 80, right? So anything between 90 and 180 is going to be graphed in the second quadrant. Keep going with me here. You guys got calcs. 180 to what would be in the third quadrant? 270, perfect. And then I go with the fourth quadrant would be anything between 270 and now we're at 360. Okay. So that's how we can tell where our graphs are going to be depending on what the angle measure is. All right, so let's talk about those angles. Remember in geometry, your angle was made up of, anybody remember what these were called here? This one and this one? It doesn't matter here anymore, but show off your geometry skills. Began with an R, ended in A. Not the letter A, but began with an R, ended in A. Ray, good job. There we go, kids. There we go. Those were rays, right? All right, you need 2 rays to make an angle. The first one, always is on the x-axis. The first ray will always land on the positive side of the x-axis. And let's get some vocabulary down. That side of the angle is always called the initial side. Did I spell that right? No, I need an I-N-I, right? Anybody? I got any spelling bee champs in the house? I-N. I-N-I. I-N-I. Okay. It's probably one of my daughter's 3rd grade spelling words coming up too, so I feel good. The initial side, always on one of the on the x-axis. The other side will be located in one of the quadrants, depending on the degree measure. That side, we're going to, this is big, this side's called the terminal side. That's because it's where it ends, terminal side. So one side of the angle, always on the x-axis, the other side depends on the angle measure. And then I drew, 4 angles in each quadrant, but let's just jump right into the fire. What do you say? So I got 145 up there, 145 degrees. First thing I'm going to ask somebody, what quadrant am I in? Don't yell it out. I'm going to call on somebody here. What quadrant? 145 would fall in quadrant 7. What quadrant does 145 fall in? See, I knew it. You're doing it to me. 7? There's no 7. I knew I should have picked new numbers. 4, you're 7? Tim, are you number 7? Yeah. One job. Which quadrant?
2.
Quadrant 2, yes. Now let's graph it. Here we go. First side of the angle is always located where? On the positive side of the x-axis. Let's do it right here. There's one side. And the other side, the terminal side, is going to fall in quadrant 2. But hey, am I looking for perfection? No. But what I am looking for is be in the ballpark. What do I mean by be in the ballpark? If this is 90 and this is 180, where does 145 fall closer to? Work on your calculator if you need to. Where does it fall closer to? Does 145 fall closer to 90 or 180?
180.
Should fall closer to 180. So darn it, put that next side closer to 180 than to 90. It should be, I should see it closer to 180. Am I looking for exactness? Absolutely not. But that thing should be closer to 180 than it is to 90. One last detail. What angle are you talking about? And what do you mean? It's that angle. Here's what are you talking about? The angle going this way? Or I could be talking about that angle going that way. If it's positive, it always goes counterclockwise. So what you guys will make after you're done is what's called a rotational arrow, showing me what direction you're going. Positive always goes counterclockwise. All right, positive always goes counterclockwise. So there's a good 145-degree angle. Anything you want to ask before we do a couple more? Go quicker. All right, 30. Where are we? Which quadrant are we? 30. We're 15. What quad? 1. There we go. Quad 1. Everyone draw your initial side on the x-axis. Should my terminal side be closer to 0 or 90 in the first quadrant if I'm graphing a 30-degree angle? Should I draw it closer to 0 or 90? 13? No 13.
It might be.
Oh, yeah, might be, yeah. 2, closer to 0 or 90? 0, yep, so make it closer to 0. And draw in your rotate. And this, I know I always see this on the quiz, so let's cut it right now. Make sure it doesn't happen. You always start your rotational arrow on the x-axis. That's where it always starts. And then it goes towards the terminal side in clockwise or counterclockwise direction. And positive is always clockwise. 295, where am I? What quad? 6, what quad am I in?
4.
Quadrant 4. First side is on the x-axis as usual. All right, before I draw this in quad 4, should it be closer to 270? Or should this be closer to 360, my terminal side? What should it be closer to? 12, where should I draw it closer to? 295. I'm going to blow a gasket here. Oh, yeah, we got numbers. We got numbers. We got a ton of numbers. Nobody has 12, though. I've called like 3 different numbers with nothing. 6?
270.
Oh, we got one. 270. Closer to 270. Boom. Rotational arrow always starts on the x-axis. Since it's positive, I go counterclockwise to the terminal side. Questions? How to graph a regular positive angle. Because now I'm going to flip the script on you. Can you graph negative angles? Darn right you can. All right. Graphing negative angles now. Hey, instead of going counterclockwise, I go clockwise. So ready? If that's 0, start going clockwise, this would be negative 90 now, right? Because positive 90 is up top. And then if I keep going around clockwise, negative 180 and negative 270. So now I go clockwise with it, clockwise. Draw an angle of negative 60 now, negative 60. All right, so, hey, the rules don't change. Starts on the x-axis. What quadrant should negative 60 be in then? 15? Negative 60. Where's negative 60 fall?
4.
4. Closer to 0 or negative 90, Howie?
Negative 90.
Good job. So make it closer to negative 90. What's the only thing that's going to change now? Ready? Rotational arrow. Starts on the x-axis, but where am I going to draw it now? Clockwise, right? This is the angle I want. So if it's negative, make sure you draw your arrow in the clockwise direction. This next question, studs only. Studs only I need. Negative 60 is the same angle as what in the positive direction? Oh, don't even zip it. In the positive direction. So I'm really saying, hey, what's that angle right there? What's that angle and how'd you get there? Okay, so negative 60 is the same as what in the positive direction? And is there a trick I can get there right away? What's up, Nick?
Is it 300?
It is 300. Yes, it is 300. How can I get there, though? What can I do to negative 60 to get to 300 pretty quickly? Add 360. Yep. Good job. So if I ever want an angle's equivalent, I add 360 to it. So if an angle is negative, add 360 to find the positive version. Don't turn your paper. I got a big vocabulary word here. So this was 60 and this was 300. Everyone agrees? See how they shared the same, what do we call this side again? Terminal. They shared the same terminal side. Two angles that share the same terminal side. I'm going to start using this word right here, coterminal. Okay, those are two angles that share the same terminal side. You could just add 360 to it. All right, add 360. So you hear the word coterminal, start thinking about adding 360. All good? All right, we're going to go a little bit quicker now because the angles may change, but the rules don't. I have an angle of negative 270 in number 5. Could somebody get me the smallest positive angle that's coterminal with it? Coterminal. It needs to be positive, so what do you do into the 270 to make it positive? Let's hear from 2. Add 360 to it. Go ahead, everyone. And I get a positive angle of 90. There you go. 90 and negative 270, same angle. Just go in different directions. All right, what about negative 110? If I want an angle coterminal with it, I add 360 and get an angle of 250. Yep. There we go. Those angles are the same exact, just different directions. Questions from you guys? Anything? All right, so we went over positive angles, we went over negative. How about something bigger than 360? Can we graph that? Yeah, we can. All right, so here I'm asking you to graph an angle of 640. Woo! 640. Now, could I do this to find the quadrant? Could I go 360 here, add another 90, keep adding another 90 until I figure out where 640 falls? Yes. But I want to challenge you now. Can you make 640 smaller so I can figure out what quadrant it is in pretty quick? How can I make 640 smaller? 640 is the same as this angle. I want to make it smaller. Jake? You going to tell me or no?
Oh, I don't know.
Oh, I thought you had your paw ready to go. How can I make 640 smaller? Dylan?
Subtract 360.
Subtract 360. Keep going all the way around again. So if I subtract 360 from it, 640 and what do I get here? 280 are the exact same angles. Now see how that goes quicker? 280, what quadrant? 8, what quadrant am I in? Who's got 8? This is not, it's ridiculous. Tomorrow, new numbers. I'm not going through this again. 13, what quadrant? 280.
Yeah, they're not
11,
4.
quadrant 4. Thanks. Starts on the x-axis. Where's 280 closer to? 270 or 360? 3. Where's 280 closer to? 270 or 360?
260. Or wait, it's 280.
No, you ready? 280. We got it in the fourth quadrant. And in the fourth quadrant, the angles go from 270 to 360. So where's this angle going to be closer to? 270. So everyone make your terminal side closer to 270. And you're ready for the change up now. Am I graphing 280? Did I ask you to graph 280? No, what did I ask you to graph? 640, right? So watch. Everyone start on the x-axis with your rotational arrow. Is that good enough?
No.
That's not 640. That's 280. So guess what we're going to have to do? Another loop-de-loop. 360 plus. All right, so if it's bigger than 360, yes, with your rotational arrow, you have to go all the way around. Past 360. It's coterminal with an angle of 280. We just subtract 360 to make it smaller. And then let's write in the rule now to make it official. Any angles whose measure greater than 360, what do? Subtract 360 from it. All right, here we go. Name the quadrant. We don't have to graph it. Just name the quadrant and tell me the smallest positive angle with 550. All right, so what's your first move now? What are you doing with 550 for me? 15, what are you doing with 550? Subtract 360. Let me know what you get there, Howie. 190. $190. Hey, should I keep subtracting 360? Why stop here? Why not do it again?
It's going to go negative.
Correct, and I'm looking for the smallest positive one. If I do it again, it'll be negative. So I'm at 190. What quadrant does that put me in? 6. Quad 3. Good. Okay, 750. 750 minus 360. Where's that put me? What did I call it? 10?
390.
You want to stop there?
No.
Because the direction said smallest positive. That's not the smallest positive. Why not? Because if you subtract 360 again, what are you going to get? Another positive angle, 30. So keep going until you find the smallest one. You might have to subtract 360 a couple times. And then what quad am I in here? I don't know why I'm asking this. 12, what quad am I in? 1. You're right there at a little.
I don't think 12's my number, but
Okay, yeah. Is there like a class group chat that I'm not aware of and be like, hey, nobody say a word every number that comes up? That's what it is. So make them go nuts. Yeah, because we get a chuckle out of that. Yeah, great. All right, how about negative angles that are less than 360? How can I simplify them? So number 9, negative 400.
still
Add 360. Yep. By adding 360. So negative 400. smallest positive measure, add 360 until I get a positive one. What's the problem here, though? What are you going to get? Negative 40. Are you going to leave it, though? It's got to be positive. So keep adding 360. It doesn't look the smallest, but it is. 320 degrees is the smallest one. If you kept adding 360, you get something bigger, but we asked for the smallest one. And the same thing with negative 900. You're going to have to go to work on that, huh? Oh boy, what's that? Negative 540? Yeah?
Yeah.
Got to keep going, right? Keep grinding. And that's what, negative 180?
Yep.
Jeez. So I end up with 180 as the smallest positive one. Last thing, and I know it's not in your packet, I'll let you go after I'm done talking. 90 degrees, and you get asked what quadrant it is in. I would never ask that. It's not in a quadrant. Okay? Anytime it falls on the line, ready to impress your friends later on today? What we call an angle that always lands on one of the lines here and not in a quadrant. Ready? Quadrantal angle. How about that? Quadrantal angle. Okay, so it doesn't land in a quadrant. It's called a quadrantal angle if it ends up on the line. Quadrantal. Wow. Quadrantal. Yeah, great. All right. Last period had no issues getting the book and the delta math done. All right, so let's do it. The book is graphing angles, and I think delta math is coterminal stuff. So let's get rocking. Got 20 minutes. 20 minutes. Yep, hurry up. I want to get some stuff done. Get the book out.